So these might be two new pens or they might be old ones. Oh, that's pretty good. Exponents and beyond is what I'm calling this. We are having no tests next week, so don't even think about tests next week. There will be no tests next week, so don't even think about that. So exponents and beyond. And the first rule of exponents you've known before. We're just going to get better with this. We're just going to get better with this. And it's this rule here. It is x to the m power times x to the n power is x to the m plus n power. And you've learned this before. This will be repeat. It will just get harder than we've done before. And an example is x to the third times x to the fifth. And the rule says to add them up and you get x to the eighth. And you might be thinking, well, it's timesing, maybe it should be x to the 15th. Well, let me just show you a little picture of why it's not. A little picture of why it's not. I've got 3 x's. I got 5 x's. I've got 8 x's. That's why it is. I got 3 x's, I got 5 x's, I got 8 x's. Yeah, so that's why that is. Okay, it's strange rule. I learned 3 things in high school. I've told some of this before. I learned quadratic formula, x equals negative b plus minus square root b squared minus 4ac over 2a. How many of you know that quadratic formula? X equals negative b plus minus square root b squared minus 4ac over 2a. How many of you can sing it? Here we go. X equals negative b plus or minus, come on, Rodrigo. B squared minus 4ac all over 2a. Like 2 of you people are in choir and the whole rest of you are not. 2 of you are good and the rest were really bad, like me. All right, yeah. So I learned that. I learned how to spell. Have I told you I learned how to spell? I before E except R C when it sounds like A is a neighbor way, except E neither the weird foreign cheek nor the efficient finish here for the chance to use later sight. Anyone else learn how to spell? I learned that. I actually learned that in 7th grade. I before E except R C when it sounds like A is a neighbor way, except E neither the weird foreign cheek nor the efficient finish here for the chance to use later sight. I before E except after C or when it sounds like A as in neighbor or way. How much do you weigh? You know, it sounds like A, so it's EI. How many learned that much? Okay, good, you just learned something. And then we learned the exception of the rules, where neither the weird foreign cheek nor the efficient financier would forfeit the chance to seize leisure at its height. So if you wanted to put the word seize, it doesn't follow the rule I before E. So in case you want to learn how to spell, it's I before E except R C when it sounds like A in the neighborhood, except neither the weird foreign cheek nor the efficient financier would forfeit the chance to seize leisure at its height. And I learned this. When multiplying numbers with a common base, add the exponents and use that sum of the common base. When multiplying numbers with a common base, add the exponents and use that sum with the common base. And that is the most useless thing. Did I say useless? Oh wait, it is the most useless thing you'll ever learn except one time. When you're multiplying numbers with a common, you know what we're doing today? We're multiplying numbers with a common base today. Oh, hi. Oh my goodness. So when multiplying numbers with a common, this is the third thing I learned. When multiplying numbers with a common base, add the exponents and use that sum of the common base. So that's a rule you have known because you all got through Algebra 2. You probably were Algebra 2 pandemic people. The next rule is this. It's a rule you've known. I'm not giving you new rules today. It is x to the m power to the n power. Now it gets different. Exponent taken to another exponent. Exponent taken to another exponent. You multiply the exponents. You multiply the exponents. So that means this. You got y to the 5th power times y to the 3rd power. You multiply and you get y to the 15th power. Well, now that's a different seeming rule. Well, this maybe can straighten it out for you. This maybe can straighten it out for you, knowing why this happens, is y to the fifth to the third power means y to the fifth times y to the fifth times y to the fifth. Means what? And now look at the rule. We're multiplying, we add the exponents. So that's why that one works. That's why that one works. If you're a strange person and you cut your pizza into 7 equal pieces and you eat all 7 of them, how many pizzas have you eaten? You've eaten 1 pizza. And we often cancel these out, but they really cancel into 1 over 1. So if we've got x over x, if you cut your pizza into x pieces, how many pieces? I don't know, I'm just a kid, how should I know? Well, if you cut it into x pieces, whatever that is, and you eat x of them, how many of the pizzas have you eaten? You've eaten 1 pizza. So are you trying to say y to the 9th over y to the 9th must be equal to 1? Well, the dividing rule and then the 0 rule are coming next. Hi, please be for me, please be for me. For second, I wish it was for me. I want to go early. So here's the dividing rule. The dividing rule is as follows. X to the m over the x to the n. Well, the multiplying rule, when you're multiplying numbers with a common base, you add the exponents, you add the exponents. Well, when you're dividing, you subtract the exponents. And in a way, I think this is almost easier to think of visually, even if you don't write it down visually. I think it's easiest. So if I have x to the 5th over x to the 3rd, the answer is x to the 5 minus 3. The answer is x to the 2nd. But I think visually, even if you don't write down the visually, this makes some sense here. We have x over x, boom, boom, boom. They all cancel away. They all become 1s. And you're left with x to the 2nd. I think visually is almost better than subtracting. Just think, well, there's 5 up here, there's 3 down here. Well, they cross out, there's 2 up. I think that's the best way to do it. Well, now comes the 0 rule. Now comes the 0 rule. So here we decided y to the 9th over y to the 9th would be 1. Well, the rule of this, y to the 9th over y to the 9th, the rule says y to the 9 minus 9, y to the 0, or as we like to say in the business, yo. This is yo. Okay, as we like to say in the business, yo. It's yo. Hey, y to the 0 is the same as 1. And this comes to the 0 rule. Any thing to 0 power equals 1. Anything to the 0 power equals 1. Anything to the 0 power equals 1. What's that equal? It equals 1. Anything to the 0 power equals 1. All right, and the final thing to look through is the negative exponent. It's the negative exponent. Do I need to start a new video recording? Uh-oh. No. I've been teaching for 9 minutes and 51 seconds. It's according to quick time. How many of you, where you live, are in the upstairs of where you live? Your room is in the upstairs. How many of you really want to be in the downstairs? How many of you? Do I have any of you? Got one. Is that maybe it? No. One? One of you? Okay, it's usually more than one, but there's one. There's one. How many of you live in the downstairs? Your room is in the downstairs. How many of you would really like to be in the upstairs? This is one of the most happy classes ever with where they are. Well, we have one person. You're upstairs, wish you could be downstairs. Well, here's what kids do. If you're upstairs and you got a negative attitude, you promise if you get to go downstairs, your attitude would change to positive attitude. So here's the negative exponent rule. If I have x to the negative 4, y to the third, over z to the negative second. X to the negative 4 has a negative attitude. I've got a negative attitude. I promise. If you let me go downstairs, my attitude will turn positive. Well, look at this. X to the negative 4th goes to the denominator. Its negative attitude becomes positive. And then after a week, you still get mad at them. But, hey, for now, okay. Y to the third power is the golden child. I'm happy where I am. No, I don't need anything, parents. I'm just fine where I am. Don't you worry about me. How many of you are that kid? There we go. All right, excellent. Y to the third has a positive attitude. It stays where it is. All right. Downstairs is z to the negative 2. It's got a negative attitude. It promises. If I go to upstairs to the numerator, I promise my negative attitude will turn positive. And look at this. The negative attitude turns positive. Wow. I'm going to stop the recording so then we can just tell secrets.